We use patterns to quickly duplicate components in ordered arrangements. Within assemblies, you can pattern components in one of three ways. So let's start with this assembly. From the Assemble tab, I'm going to pick Pattern. From the Pattern tab, I can choose between the three pattern types. But notice that Inventor has prompted me to select the components to pattern. Now, I could have picked them before, but in this case, I'm going to select them now. As there's only one component in this assembly, I will select it. Let's change the type to rectangular because that's what we're after. And the rectangular layout arranges the selected components into repeating columns and rows. So next, I need to define the columns and rows. Rows are optional, and you can pattern actually just in one direction. You do need at least a column. I'm going to select one of the origin axes as the pattern direction, which I can do right from the dialog. Let's select the y-axis. Now notice that as I change the number of occurrences and the distance between, we can see that the preview updates. I will continue to adjust the values until I'm satisfied. Which, now I'm satisfied with the occurrence locations. Inventor defaults to patterning in what it sets as the positive direction. However, I can easily flip it or specify negative distance to reverse the direction. Or perhaps you have situations where you want the original instance to be in the middle. But you can see with the even count, the pattern is not symmetrical. We have 3 to one side and only 2 to the other. So middle definitely works best when you have an odd number count. Let's bump the count to 7, and now the original is truly in the middle. After selecting OK, Inventor creates the pattern. We can see in the browser that the pattern has been created. I'm going to right-click on it and pick Edit. As with just about every feature within Inventor, we can make changes to it after creating it. So I've changed my mind, and I no longer want this to be in the middle. And I don't want so many brew kits. But with less occurrences, I also need to adjust the spacing. Now I'm satisfied with the column settings. Let's configure the rows. I could do the same by picking an origin axis, but instead, I'm going to pick an existing edge to set the direction. Back in the dialog, I will set the number and the distances between occurrences. Of course, I have the same flip and middle options as I did with the columns. Patterns, just like all features in Inventor, are parametric. I'm going to rename the row count to be a named parameter called row count. Let's click OK to return the model. Now, if we go look at the parameters, we can see that we have one named parameter, which we just created. Let's adjust its value to 3. And when I click Done, we can see the pattern is updated to match. Looking at the pattern, I realize that we do not want the one in the middle. From the browser, I will expand the feature, revealing its occurrences. I will find that particular occurrence, right-click on it, and select Suppress. Now, even with the occurrences suppressed, it's still a pattern. In fact, let's go make a change to it. Let's adjust the column's count and distance. After selecting OK, notice that it updated and it kept that instance suppressed. Now what I can see here is there's 4 times 3 brew kits. So my math tells me there should be 12, but minus the suppressed one means there should only be 11. Let's go to the bill of materials. And notice that the quantity is correct and it's showing there's 11. So the bill of materials will always match the number of occurrences defined by the pattern. Now, as we saw before from the browser, we can access the pattern occurrences. More than suppressing, you can also make changes to each instance as you would change any other component instance. I want the second one to be a different color, so select the occurrence, and from the color dropdown, select blue. We can also control visibility, its bomb structure, and change representations, all from the right-click menu. Now let's open the component in its own window. I already have it open, so let's just pick its tab. I'm going to delete the extra canister. And now let's make a change to the existing pattern, changing the count to 3. Now, this new occurrence is not in the right position, as you can probably see. The spacing is good, but I prefer it to be on top of the frame. In the browser, I will right-click on the third occurrence and select Independent. It's subtle, but notice the browser icon has changed. Inventor has also added another instance of the component just above the pattern feature. What's actually happened is Inventor suppressed the occurrence and inserted a new instance at the exact same location as the original. The new instance is unconstrained, so I can position where I need it, including constraining it to the frame. I'm going to edit the pattern, but that third occurrence has reappeared. But don't worry, this is only temporary as I adjust the feature's parameters. Let's change the spacing and click OK. That third occurrence resuppresses. And we can see the change to the pattern did not affect the occurrence that we made independent. So what would happen if I turned off the independent option? Well, it's no longer suppressed, and I've restored the instance to the pattern. However, it did not remove the independent copy and left that as is. So it's probably a bit of an unexpected behavior, but Inventor does what Inventor does. Let's move over to a different assembly. What we have here is two parts, and I'd like to pattern this part around this particular curved surface. So let's start the pattern command. I will select the green component and toggle over to the circular pattern option. And as with rectangular, I could select an origin axis. So use an origin axis to set the center of the pattern. But in this case, I will select the curved face to use as the center of rotation. And you can select curved edges, curved faces, really anything round. Let's set the number of occurrences. And because it's set to incremental, it's actually doing degrees between instances. Instead, I will select fitted because I want this to be fitted within 360 degrees. So you have control over setting the total angle to fit the occurrences or set the incremental distance between occurrences. I'll select OK to apply the pattern. Now let's switch over to the front view and notice how Inventor rotated each occurrence as it created the pattern. Now let's go back, let's edit the pattern. I'm going to change the orientation to fix, and we change the behavior. By being fixed, all instances are fixed at the same orientation. So still a circular pattern, just not rotating each occurrence as it goes through the pattern. Now with fixed, you may run into instances where the components are not spaced properly, so you can actually adjust the pattern radius, selecting your own. You can see how the pattern changes based on my selections. Now I was actually happy with the pattern before, so I'm just going to cancel this and put this back to what it was. So that's how you create circular patterns within assemblies. Let's jump over to another assembly and dive into the third patterning option. As you can see, I've already inserted the first fastener, but I'd like to pattern it through all the holes. So let's start the pattern command. I'm going to pick the fastener as the component to pattern, and I will activate the associative option. With this option, you link the pattern to an existing feature pattern. As we can see, this gold-colored part, the spindle plate, has an existing pattern. Otherwise, Inventor would not let me select anything. Although, it looks like we have a problem. The spacing appears correct, but the fasteners are out in space and are not aligned with the holes. So let's cancel the operation. A limitation with the associative option is you need to place the first instance of the component at the first instance of the feature pattern. So I'm going to delete the constraint, and let's reposition the fastener. So let's just apply a constraint, and then I'll just drag the component down so it's close to the hole. Now let's start the pattern again, using the same component and using the associative option. Now it looks correct. So let's click OK to return to the model, and we can see that it's added a fastener to every hole in that feature pattern. Now the next problem is that we have a part interfering with that spindle plate. So let's go into the plate. Let's modify that rectangular pattern. In this case, it's a pattern of holes. And let's change the count and adjust the spacing. Now, when I click OK, I can see that it's updated that feature pattern. And when we return to the assembly, notice how the component pattern updates to match the changes. And that's the power of the associative, is that you've associated it to a feature pattern. Feature pattern changes, number of instances, number of occurrences, and the associated assembly pattern updates to match. Now let's change the size of that fastener, and let's bump it up in size. I'm not going to do the replace all because I don't have to. Why? Because it's part of a pattern, and the pattern automatically updates with changes to the component. So that's one way of using existing feature patterns. That associative pattern option is also built into the Place from Content Center. So let's delete the pattern and the fastener. I'll select Place from Content Center. Notice that I do have auto drop turned on, and this is important. I'll select a countersunk screw and click OK. As auto drop is enabled, it's looking for me to select a feature so it can both size and constrain the part. Now, because the follow pattern option is enabled, it's associated itself to the existing feature pattern, just like we saw before. However, unlike the associative pattern feature, the place from Content Center is smart enough to recognize the pattern and locate the occurrences correctly. You don't have to place a first instance at the first instance of the feature pattern. You can place it at any hole of the pattern. Now, follow pattern is not doing anything unique. We can see it actually created an associative pattern and placed the components correctly. However, I cannot make any changes here, it's only read-only. This is because I use the Content Center with AutoDrop and would need to edit it with the Content Center tools to make a change. Now again, if I go back to the spindle plate and we make a change, not only does the feature pattern update, but like we saw before, the assembly pattern also updates to match. It's added those fasteners to the new hole occurrences. Now let's delete the pattern and the Content Center component so we can explore the other Content Center option. Now let's go back in and edit the spindle plate. I'm going to remove the feature pattern. And let's add some holes with some randomly placed points. So it's no longer a pattern. I just have some holes located within the part. I'm also going to add a hole that is different than the others in type and size and other details. So again, this isn't a pattern, it's just a collection of same type of holes. So let's go back, let's do a place from Content Center, and we'll select that same hole. Now notice the option has changed. So as it no longer finds a feature pattern, instead we'll use the Insert Multiple option. So now Inventor has inserted a fastener at every like hole, like the originally selected one. So based on where I position the fastener, it goes out and looks for holes that are exactly the same, and it uses those to go and locate the rest of the fasteners. But we can see that it did not insert a component at the one hole with the different sizing. So there you have it. With an Inventor, we can create rectangular, circular, and associative patterns at the assembly level. We can select parts, subassemblies, really any component that's in there. Plus, there's a couple hidden gems found within the Content Center when you're using AutoDrop.